Good afternoon, everyone. Today we're going to find the capacity of this igloo that is made up of a half cylinder in this part in the entrance and half of a sphere in the bigger portion. And of course, we connect the capacity to hold any kind of liquid to the volume of an object, right? So what we're really looking for in this example is the volume of this composite shape altogether. So let's go ahead and do that. We'll say the volume in total is composed of the volume of the half cylinder, being the entrance, plus the volume of the half sphere in the main part of the igloo. And so let's go ahead and calculate those bits. So we know that the volume of a cylinder is the area of the base times the height, which is pi r squared times h. And so half of that means pi r squared h over 2. Plus, we know the volume of a full sphere is 4/3 pi r cubed, and so half of that, instead of 4/3, of course, we'll only have 2/3 pi r cubed. And so now we have the radius of our half cylinder, we have the height, but since it's laid flat, that's really the length of it. And since this is a half a sphere, the only real dimension that it has is radius. And so the radius, right, the height from let's say the equator of the sphere and the apex is 1.3 meters. And so that'll serve as our half spheres or our hemispheres radius. And so now it's just a matter of plugging in our values and computing properly. And so we'll have pi times here for the half cylinder, our radius is 1.5 meters. And so 1.5 squared times our height of 2.1 divided by 2, since we only have half of a cylinder, and we add to that 2/3 of pi times, again, the radius. That should not be, let's say 11.3, because that doesn't make much sense. I meant to put 11.3. I'm terribly sorry, viewers. So with that in mind, since this is only 1.5, right, this kind of fits the bill. We'll have a radius of 11.3 meters. Let's plug that in. And we have that being cubed. And now it's simply a matter of computing through all of these messy values. You can go ahead and do that, and we'll check our answers together. So we have pi times 1.5 squared, so that's 2.25 times 2.1 times pi, all divided by 2, giving us 7.42, roughly, to 2 decimal places, plus 11.3 cubed times 2 pi over 3, that's roughly 3,022.00 to 2 decimal places. Of course, this hemisphere part of the object is far greater than this little entrance. And so altogether, the entire volume is 3,079, whoopsies, that's not it, 3,029.42. And for our units, we're dealing with capacity, a 3D kind of measure, and we have meters, and so our volume will be measured in cubic meters, right? And now relating this back to the capacity to hold any kind of liquid, like water, right? We remind ourselves of our unit conversion, I guess, that 1,000 liters fit inside of 1 cubic meter. Every cubic meter can hold 1,000 liters. And so here we have 3,029.42 cubic meters, which is an absolutely massive quantity. 11.3 meters, that's pretty high. That's somewhere around 35 feet high. So that's a lot of water, certainly. So that means that we have 3,029.42 groups of 1,000 liters. And so let's go and compute that. So our capacity is equal to 3,029.42 times 1,000 liters, right? Which will give us 3029420 liters. Over 3 million liters of water could be poured inside of our massive igloo here. And this is me saying hi to all of you wonderful viewers. So I hope this helps. Thanks for watching. Thank you so much for watching, and have a great day.